Hello students. So in this lecture I'm going to discuss about photodiode. Before discussing photodiode, I told you when I was discussing the photoconductive cell, I told you in brief that semiconductor light detectors can be divided into two major categories, that is junction devices and bulk effect devices. The junction devices, when operated in photoconductive mode, utilize the reverse characteristic of a PN junction. So this photodiode will fall under this junction devices group. The photodiode topic that I'm going to discuss in this lecture will fall under this junction devices group. Whereas and in junction devices under reverse bias, the PN junction acts as a light controlled current source. Whereas bulk effect devices, bulk effect photoconductors have no junction and the bulk resistivity decreases with increasing illumination, allowing more photocurrent to flow. So I've already discussed the bulk effect devices when I was discussing this photoconductive cell, that is photoconductive detectors fall under this bulk effect devices group and photodiode fall under this junction devices group. So what is a photodiode? Photodiode is a light detector semiconductor device, that is a special type of PN junction device that generates current when exposed to light. That is, it converts light energy into electrical energy and it works on the principle of photoelectric effect. So it is also known as photodetector or photosensor because it is detecting the light and generating the detecting the light and converting it into the electrical energy. So this is the symbolic representation of photodiode. This is the symbolic representation of photodiode. So as I've told you, photodiodes are special type of PN junction device which is similar to semiconductor diodes, except that they may be either exposed or packaged with a window to allow light to reach the sensitive part of the device. So it is similar to the regular semiconductor diodes. The only difference is light falls in the photodiode, that is in the depletion region of the photodiode, whereas there is no light in the semiconductor diode falling on its depletion region. So the current is generated when current is generated through the photodiode, the current is generated when photons are absorbed in the depletion region of the photodiode. So let me discuss the construction of photodiode. So this is the construction of photodiode. It is, as I've told you, it is a PN junction diode. This is the p-type semiconductor, this is the n-type semiconductor. So it is a PN junction diode where this junction, that is this depletion region or the junction, is formed by p-type semiconductor and n-type semiconductor material. So according to this figure, it is formed by this depletion region is formed by the diffusion of this whole construction is formed by the diffusion of lightly doped p-type impurity into the heavily doped n-type impurity, and the area between the p-type and the n-type impurity is called the depletion region. Here the contact pads are used, and the contact pads at the n-type area are called the cathode, whereas the contact pads at the p-type area are called the anode. So some portion now, this is the front area, this is the front area of the of this photodiode. So some portion of the front area of the diode is called the active area. This is called the active area. Active area means it is coated with anti-reflection material. This front area, which is called the active area, it is coated with the anti-reflection material to reduce the reflection of light. That is, light energy is not lost and the maximum of it can be converted into current, and rest of the front area, like this, rest of the front area of the diode is called non-active area, and it is coated with thick layer of silicon dioxide. Now this was all about the construction of photodiode. Now moving on to the operational modes of photodiode. First I would say, since this is coated with anti-reflection material, so the light will fall on this part. So when this junction of photodiode is illuminated with light source, the photons strike the junction surface. The light energy in the form of photons supplies sufficient energy to junction to create a number of electron hole pairs in the junction. So because of this incident light, a number of electron hole pairs will get generated in the depletion region, because the photons with sufficient energy are striking the depletion region and generating the electron hole pairs. They are transferring their energy to the electrons and releasing the electrons from the bond, and electron hole pairs are getting generated in this depletion region. So there are two modes of operation of photodiodes. The operational modes of photodiodes are, that is, photodiode basically operates in two modes: photovoltaic mode and photoconductive mode. So what is photovoltaic mode? When the diode is operated without reverse bias, it is said to be operated in photovoltaic mode. And what is photoconductive mode? When the photodiode operates in reverse biased mode, it is called photoconductive mode. So I have already discussed the photovoltaic mode in my previous lectures, or you can say photovoltaic cell I have already discussed. That is, when the diode is operated without any reverse bias. That is, if there is no biasing applied to the anode and cathode part, then it will work in the photovoltaic mode. So this thing I have already discussed in photovoltaic cell. Here also I am giving a short description what happens in photovoltaic mode. The free electrons so generated due to the incoming light in the depletion region can quickly come to the N side of the junction due to the potential barrier of the junction, that is the negative ions in the P side. Similarly, the holes so generated due to the photons in the depletion region can quickly come to the P side of the junction due to the positive ions in the N side of the depletion region. So therefore a voltage is set up which is known as photovoltage. So if we connect a small load, we are not biasing, we are connecting a small load across this anode and cathode. So if we connect a small load across the junction, there will be a tiny current flowing through it. So this is the function of photovoltaic mode that I have already discussed in photovoltaic cell. So here I will be discussing the photoconductive mode of the photodiode. So in photoconductive mode, what happens when the photodiode operates in reversed biased mode? It is called photoconductive mode. That is, which means the negative voltage is applied at the anode and the positive voltage is applied at the cathode. So this is the criteria for photodiode to be operated in photoconductive mode. So I'll be discussing about the working of photodiode in photoconductive mode in my next lecture. I'm ending this class here. Thank you.